This is Chapter 6, Section 2, Representing Functions, Day 1. It actually starts on page 259 in your textbook. Today we are going to be able to represent a function in 3 different forms. You've already done this. Linear functions. Y equals mx plus b. So a linear equation is a type of function. You've already seen this. We've seen an equation in slope-intercept form. You've seen an equation in a table, and you've seen equations graphed. So this will be a little review. Janice wants to enroll in a Spanish class at a language school. She has to pay a registration fee of $100 plus $20 for every hour-long lesson that she takes. The relation between the total amount she pays and the number of hours of lessons she takes is a function. It's a linear function. So the input is the number of hours. That's the input is the x, which is also the independent variable. So it's the x. What would you put on the x-axis? You would put hours, the number of hours on the x-axis. The output is the amount of money that she's going to pay. The total that she pays or paid. That's the dependent variable y. To turn this function word problem into equation, we need to understand that the input can be represented as the x, and the output can be represented as the y. And don't forget that the rate that she's paying is really the slope, m, the rate of change, and the initial amount is the starting point, which we call the y-intercept. So input, the x values, output, the y values. The rate in this example was $20 per class for every hour. So the rate goes up $20 for every hour. Y over x, $20 up for every 1 hour x in time. The initial fee was $100. Therefore, the function, the equation of this is y equals 20x plus 100, the y-intercept. So 20x plus 100. To create a table of values from our function equation, yes, it's a linear function, a linear equation, y equals 20x plus 100. Select values for x to plug in and solve for the y. Okay, well, I've already selected them for you. When x is 0, y is going to be 100. When x is 1 here, you get 20 times 1 plus 100, 120. When x is 2, 20 times 2, that's 40 plus 100, 140. Draw this table. Oh, you don't have to draw this in your spiral. You already have it on your notes here. So ignore that. The graph of the problem would be represented in the following way. So 1 hour was $120, 0 hours, because there's an initiation fee of $100, so 0, 1, 120, 2, 140, 3, yes, if we kept going, 160, and we could put that point over here, 3, 160. And yes, you can see that my y values are going up by 20, while my x values are going up by 1. Y over x, my slope, 20 over 1. Yes, that makes sense. Oops. I did want to go over this think math little part here. Suppose Janice takes 20 hours total of lessons. What are the greatest input and output values then for the function? Well, if x is 20, that's the greatest input. The hours is the x. So our x, with this little think math here, x would be 20, right? That's the greatest input, and the greatest output would be, okay, well, 20 times 20, right? Put it in for x, y equals 20x plus 100. 20 times 20, that's 400. So our y, our greatest output value, would be 500. Greatest input would be the number of hours, 20. Greatest output would be 500. Nope, we don't have to glue this in. Don't Okay, so you have it right here on your paper, don't worry about that. So a tank contains 8 gallons of water. Water is then pumped into the tank at a rate of 2 gallons per minute. The total amount of water in the tank, Y gallons, is a function of the number of minutes, X. The water has been pumped into the tank. Write a verbal description of the function. Then write an algebraic equation for the function. So the total amount of water I'm just going to abbreviate it H2O here, in the tank equals the amount of water at first plus 2 gallons per minute, right? The total amount of water in the tank equals the initial amount, the initial water in the tank. Oh, I could use H2O again. Plus 2 gallons per minute. That's my rate, that's my slope, my rate of change. Times the number of minutes, right? Not enough room here. So that's the verbal description. My equation would be, okay, it starts with 8. So the initial water in the tank, as I wrote in English, plus, so my equation, I'm going to put it under here under B because I ran out of room, plus 2 gallons per minute, the rate, the slope of, and times however many minutes. So y equals 2x plus 8 or y equals 8 plus 2x. Doesn't matter the order, it's commutative. Construct a table of x and y values for this function. Okay, well, x is time, right? So can't have negatives. That doesn't make sense. I'm going to start at, well, let's start at time 0. 0, 8, time 1, so 1 minute. We would have 1 minute, we would have 10 gallons of water. At 2 minutes, we would have 4 plus 8 is 12 gallons of water. At 3 minutes, we would have 14 gallons of water. And I don't know if this graph will go up higher than that. I might not even be able to graph those. Ah, sure, we can graph those. We can count by 2's on our axes. 2, 4, 6, 8, 10, 12, 14. And my time in minutes, 1, 2, 3, 4. So 0, 8 would be on the y-axis here. And then 110, 212, going up 2 gallons, up 2 and over 1, up 2 for every minute. So 314, we could even get 416 on here, right? And yes, we could get 518 on here as well. We could keep going with this. Okay, so let's label our axes. This is minute, time in minutes. Always put your units on there. And this is gallons in the tank, right? Water has been pumped into the tank. So this is water, and it's measured in gallons. So put your units on there. And the title of this could be water pumping into a tank. Water pumped in a tank. Come off the edge there. Water pumped in a tank. So make sure you're labeling your axes, full labels, giving it a title, graphing. So now we've seen a linear function, linear equation, in word format, verbal description, in an equation, y equals 2x plus 8, in a table of values, my XY table, and as a graph. 4 ways to show a linear function. Try this one with your partner. First answer these questions and then write a linear equation. Create a table of values for x values from 1 to 3. Step 3, plot the points on the graph using a horizontal scale of 1 and a vertical scale of 6. So the y-axis is going up by 6s. A game shop rents out video games at a rate of $6 per game. The total amount of money the shop collects, y dollars, is a function of the number of games x that the shop rents out. What is the input? What is the x? Well, the x is the number of games rented, right? I could have just said games rented. Would fit on the blank a lot better. The y is the total money. What is the rate? Okay, it's $6 per game. That word per helps us there. It's got 2 labels, the $sign and game. So there's my rate. What is the rate? $6 per game. And what's the initial amount? Is there a fee to do this to begin with? No. So the initial amount is $0. So I'm going to ask you to fill in the equation with that information, y, x, m, and b on the other side. Give me a table of values for 0 to 1, or 1 to 3 rather. Label your table, label your graph, give it a title, and we'll go over this tomorrow.